In this problem, it is given that a particle P is sliding down the hemispherical surface like this. It passes point A time 0 at this time. Horizontal component of its velocity is phi. That means it goes along this line. When it passes this point A, it has got the actual velocity here, but its horizontal component is phi. Horizontal component is v. At the same instant, the horizontal component of its at this instant, the horizontal component of its velocity is v. Okay, a bead q of the same mass at p. A bead q. This is bead p. There is a bead q of the same mass is ejected from A at the same point A with a speed v along the straight line. Speed v, this speed v is along the straight line AB. This A and this B. Okay. Now, friction between these things neglected, TP and TQ. Now, here, this horizontal velocity, here it increases. So, this is V dash. And again, at V, I am telling for the particle P. For the particle Q, this V is constant. Okay. And for this particle P, V increases, then decreases. And we know that very well that VT graph, the area under VT graph is the displacement. So we are concerned about the x-axis displacement. X-axis displacement here, the x-axis is here. We are not concerned about the y-axis. So for particle P and for particle Q, we draw the V versus T. Now at start, this is V, and then it will increase to how much? This will be, as I said, V dash at the bottom, and then back to V again. So this is the time Tp. Now for the particle Q velocity, so it is V and it remains V. So this much area, this time is Tq. But as the x displacements are equal in both cases, because the x displacement is AB, so the area under this curve, which is the x displacement, is equal to the area under this curve because the x displacement is same. So obviously from here you see that obviously V increases, so Tp should be lesser than Tq if it has the same area, because baki things are same. This is same, but this velocity, it has increased, so a lesser time is needed. And here V is constant, it's flat V. So therefore obviously as the area under the curve is same under both cases, so Tp is less than Tq.